Good day, everyone. I'm Mr. Florendo, your Algebra 1 teacher. Today, week 15, we will discuss about adding and subtracting rational expression in chapter 11, lesson number 4, that is on textbook pages 684 to 689. Materials needed: your textbook, notebook, and of course, your pen. Our objective is to learn how to add and subtract rational expression. Example number 1. Add or subtract. Identify any x values for which the expression is undefined. X minus 3 over x plus 4 plus x minus 2 over x plus 4. As you can see here, our denominators here are the same. So what we're going to do is add the numerators. You will have x minus 3 plus x minus 2 over the denominator, that is x plus 4. Then combine like terms. X plus x, that is 2x, negative 3 minus 2, that is negative 5 over the denominator, that is x plus 4. Since we don't have common factors here, that is the simplified form already. Then identify the x values that makes the expression undefined. So the expression is undefined at x equals to negative 4 because this value makes x plus 4 equal to 0. Another example. 3x minus 4 over x squared plus 1 minus 6x plus 1 over x squared plus 1. Again, you can see here the denominators here are the same. That is x squared plus 1. So simply subtract your numerators. That could be 3x minus 4 minus the quantity of 6x plus 1 over your denominator, that is x squared plus 1. And then distribute the negative sign. That could be 3x minus 4 minus 6 and then minus 1 over x squared plus 1. Then combine like terms. 3x minus 6x, that is negative 3x. Negative 4 minus 1, that is negative 5 over the denominator, that is x squared. Since we don't have common factors here, that's the final answer already. So in the case of the value of your x that makes the expression undefined, there is no real value of x for which x squared plus 1 equals to 1. So the expression is always defined for any values of your x. To add or subtract a rational expression with unlike denominators, first find the least common denominator, or the LCD. So the LCD is the least common multiple of the polynomials in the denominators. So the least common multiple, or LCM, of polynomials, to find that one, first, we're going to factor each polynomial completely and then write any repeated factors as power. For example, x cubed plus 6x squared plus 9x. So x is common in each term. We can take out that one. And the other factor is a perfect square trinomial, and you can write that one as x plus 3 raised to the power of 2. Then number 2, list the different factors. If the polynomials have common factors, use the highest power of each common factor. Example, find the least common multiple for each pair. 4x raised to 2 times y raised to 3 and 6x raised to 4 times y raised to 5. So what we're going to do is to write first the given expression in prime factorization. So we will have 4x raised to 2, that is equal to, the prime factorization of 4 is 2 times 2. Simply copy the other variables, x squared times y raised to 3. Then for the second one, prime factorization again of 6, that is 3 times 2. Then x raised to 4 times y raised to 5. So the LCM here is, we don't have common factor, just bring down. We have common factor here, bring down the factor with the highest exponent, that is 2, 3 also. X raised to 2 and x raised to 4, we have common factors, bring down the factor with the highest exponent, that is x raised to 4. And likewise for y cubed and y raised to 5, bring down the expression with the highest exponent. And then multiply that one, that's the LCM, that is 12x raised to 4 times y raised to 5. Letter B. First, we're going to factor out this one. That is x squared minus 2x minus 3. Possible factors of x squared, we have x and x. For negative 3, whose sum is negative 2, so we have x minus 3 times x plus 1. The second expression, x squared minus x, and then minus 6. Possible factors of negative 6, whose sum is negative 1. So we could have this one as x minus 3 and x plus 2. So LCM would be common factors, bring down the factor with the highest exponent. We will have x minus 3. Those factors with no common, bring down them. That is x plus 1 and x plus 2. Then multiply that one. That could be the LCM is x minus 3 times x plus 1 times x plus 2. So to add a rational expression with unlike denominators, first we're going to rewrite both expression with the LCD. So this process is similar to adding fractions. Example, 2 over 6 plus 3 over 10. You can factor first your denominators here. You could have 2 times 3 and then 2 times 5 respectively for 6 and 10 as your denominators. So the LCD here would be 2 times 3 times 5, that is 30. So what number will I multiply to 6 to make this one 30? So that is 5. So we're going to multiply also the numerator by 5. The same case here. What number will multiply to 10 to make it 30? That is 3. So the same also, multiply the numerator by 3. So simplifying this one, that could be 2 times 5 equals to 10 over 30 plus 3 times 3, that is 9 over 30. The denominators here already are the same. So what we're going to do is add the numerators here. 10 plus 9, that is 19 over 30. And 19 over 30 is already in the simplest form. Example, how do we add rational expression with different denominators? And then identify any x values for which the expression is undefined. X minus 3 over x squared plus 3x minus 4 plus 2x over x plus 4. First, we're going to factor out your denominators here. So that is x minus 3 over possible factors of x squared plus 3x minus 3 are x plus 4 and x minus 1. Factors of negative 4 whose sum is 3 is positive 4 and negative 1. And then the other one, we cannot factor out that one, so simply copy. After that, find the LCD. So the LCD would be, we have common factors here, copy the factor with the highest exponent. We have x minus 1, we have common, so the LCD would be x plus 4 times x minus 1. Since in the first expression that is exactly the same with the LCD, simply copy that one. X minus 3 over x plus 4 times x minus 1 plus. In the second expression, I only have here x plus 4. But the LCD is x plus 4 times x minus 1. So we need to multiply your numerator and denominator by x minus 1 over x minus 1. So doing that one, we're going to have now to add the numerators. That could be x minus 3 plus the product of 2x times x minus 1 over the LCD. Simplifying the numerator, that could be 2x squared minus x minus 3 over x plus 4 times x minus 1. Rewriting this one as a factored or expanded form, that could be 2x squared minus x minus 3 over x plus 4 times x minus 1, or you could have 2x squared minus x minus 3 over x squared plus 3x minus 4. So the expression is undefined at x equals to negative 4 and positive 1 because these values of x make the factors x plus 1 and x minus 1 equal to 0. Another example, subtract 2x squared minus 30 over x squared minus 9 minus x plus 5 over x plus 3. And then identify any x values for which the expression is undefined. So first, we need to factor the denominators. Copy the numerator, 2x squared minus 30 over x squared minus 9 is difference of two squares. So the possible factors of this one would be the product of the difference and sum of two terms. So that could be x minus 3 times x plus 3 minus. So here we cannot factor out this one, so simply copy. x plus 5 over x plus 3. Therefore, find now the LCD. So we have common factors here, x plus 3 and x plus 3. So copy the common factor with the highest exponent. So that could be x plus 3. So the other, multiply that one. That is x minus 3. So therefore, the LCD here is x minus 3 times x plus 3. Okay, so we're going to rewrite that one. That could be 2x squared minus 30 over. In the first one, x squared is the same as your LCD. So we copy only that one. X minus 3 times x plus 3 minus. So in the second expression, I only have here x plus 3. So I will be multiplying this one since the LCD is x minus 3 and x plus 3. I have already x plus 3, so what is missing is x minus 3. So multiply your numerator by x minus 3 and your denominator by x minus 3 to come up with the same denominator. Subtract now the numerators. So you will have 2x squared minus 30 minus the product of x plus 5 and x minus 3 over the LCD. That is x minus 3 times x plus 3. Then multiply the binomials in your numerator. That could be 2x squared minus 30 minus the quantity of x squared plus 2x minus 15. That is the product of x plus 5 times x minus 3. You can apply here distributive property and then combine like terms over the denominator, that is x minus 3 times x plus 3. And then distribute the negative sign. That would be 2x squared minus 30 minus x squared minus 2x plus 15 over x minus 3 times x plus 3. Combine or write the numerator in standard form. 2x squared minus x squared, that is x squared. Then negative 2x, negative 30 plus 15, that is negative 15 over x minus 3 times x plus 13. Factor the numerator, that is x plus 5 and times x minus 3 over x minus 3 times x plus 3. Divide out common factors. So you will have x minus 5 over x minus 3. The expression is undefined at x equals to 3 and negative 3 because these values of x make the factors x plus 3 and x minus 3 equal to 0. For your exercises, please refer to your weekly plan and Pearson account. Thank you and God bless you all.